Hello students, today we are going to study chapter 7 triangles. Some important points are there. First one, figures whose shapes and size are equal are called congruent figures. Congruent figures means exactly the same figures, okay? That is two circles having same radius. If two circles have same radius, then they are called congruent circles. Second, congruent triangles have a corresponding sides and angles are equal. If two triangles are congruent, then their corresponding sides are equal and corresponding angles are equal. Now some criteria for congruence of triangles. First one, SAS congruence, that is side angle side congruent. Two triangles are congruent. Two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and included angle of the other triangle. That is, in triangle ABC and PQR, two sides AB equal to PQ and AC equal to PR and the included angle, that is angle A equal to angle P, then we can say that triangle ABC congruent to triangle PQR by SAS congruence. Okay. Second one, ASA congruence. Two triangles are congruent if two angles and the included side of one triangle are equal to two angles and the included side of the other triangle. ASA, that is two angles and included side. Okay. That is in triangle ABC and PQR, if angle B equal to angle Q and angle A equal to angle P and the included side, that is angle between these two side between these two angles, that is AB equal to PQ, then we can say that triangle ABC congruent to triangle PQR by ASA congruence. Okay, in triangle ABC and PQR, if angle A equal to angle P, B equal to Q and AB equal to PQ, then the triangles are congruent by ASA congruence. Third one, AAS congruence, that is two angles and non-included side. Okay, if any two pairs of angles and one pair of corresponding sides are equal, then the triangles are congruent by AAS congruence. Two angles and non-included sides are equal, then they are congruent by AAS congruence. That is, in triangle ABC and PQR, if angle B equal to angle Q and angle A equal to angle P and BC equal to QR. These two are non-included side. That is, these two sides are not in between these two angles. So we can say that triangle ABC congruent to triangle PQR by AAS congruence. SSS congruence, that is if three sides of one triangle are equal to three sides of another triangle, then the two triangles are congruent by SSS congruence. Okay, that is in triangles ABC and PQR, if we have AB equal to PQ, BC equal to QR, AC equal to PR, that is corresponding sides are equal, then we can say that triangle ABC congruent to triangle PQR by SSS congruence. Fifth congruence, that is RHS congruence, it is only for right triangles. If in two right triangles, the hypotenuse and one side of one triangle are equal to hypotenuse and one side of another triangle, then the two triangles are congruent. Okay, that is if in triangle ABC and PQR, if these two are right triangles, we have hypotenuse AC equal to hypotenuse PR and any other side, that is AB equal to PQ, then we can say that triangle PQR or ABC, triangle ABC congruent to triangle PQR, reason by RHS congruence. Right angle, hypotenuse, side. Right angle, hypotenuse and one of the side. By RHS congruence, these two triangles are congruent. Now fourth important point, angles opposite to equal sides of a triangle are equal. That is, if in triangle ABC we have given that AB equal to AC, then angles opposite to them are also equal. That is, angle B equal to angle C. Angles opposite to equal sides of a triangle are equal. Fifth one, sides opposite to equal angles of a triangle are equal. That is, if B equal to C, angle B equal to C, then opposite side, that is AC equal to AB. Okay, sides opposite to equal angles are equal. Exercise 7.1, first question. In quadrilateral ACBD, AC equal to AD, and AB bisects angle A. AB bisects angle A means we have angle 1 equal to angle 2, isn't it? Show that triangle ABC congruent to triangle ABD. We have to prove that triangle ABC congruent to triangle ABD. What can you say about BC and BD? BC and BD, we have to say whether they are equal or not. Okay. Solution. In triangles ABC and ABD. In triangles ABC and ABD. In triangles ABC and ABD, we have AC equal to AD. AC equal to AD, reason given. It is given that these two sides are equal, isn't it? Now angle 1 equal to angle 2, reason since AB is the bisector of angle CAD. We have given that AB is the bisector of this angle A. So angle 1 equal to angle 2. Angle 1 equal to angle 2, reason given, or since AB is the bisector of angle A. It is given that AB is the bisector. Therefore, we get angle 1 equal to angle 2. Now, AB equal to AB, reason common. For both these triangles, AB is common, isn't it? AB equal to AB, reason common. Common side. Hence, we can say that triangle ABC congruent to triangle ABD by SAS congruence. Two sides and a include angle, isn't it? Therefore, triangle ABC congruent to triangle ABD, reason by SAS congruence. By SAS congruence, these two triangles are congruent. Hence, we get BC should be equal to BD, reason corresponding sides of congruent triangles are equal. Therefore, we get BC equal to BD, reason corresponding sides of congruent triangles, that is CPCT. Okay, CPCT, that is corresponding parts of congruent triangles. Okay. Second question. ABCD is a quadrilateral in which AD equal to BC and angle DAB equal to angle CBA. Prove that triangle ABD congruent to triangle BAC, BD equal to AC, angle ABD equal to angle BAC. We have given that quadrilateral ABCD is a quadrilateral in which AD equal to BC, angle DAB equal to angle ABC or CBA, and we have to prove that triangle ABD congruent to triangle BAC. These two triangles. This is the first triangle and this is the second triangle. Okay, these two triangles are congruent, that we have to prove. Solution. In triangles ABD and BAC, in these two triangles, we have AB equal to BC, reason given. AB equal to BC, reason given. It is given that these two sides are equal. Now, angle BAD or DAB. Angle BAD equal to angle ABC, reason given, isn't it? Or angle DAB. Angle DAB equal to angle CBA, reason given. Angle DAB equal to angle CBA, reason given. Now one side, this is the second angle. Now third side, this is common to both these two triangles, isn't it? Therefore, AB equal to AB or BA. Both are same, reason common. common side. Hence we can say that triangle ABD congruent to triangle BAC by SAS congruence. Two sides and include angle. Here also two sides include angle, isn't it? Therefore we get triangle ABD congruent to triangle BAC, reason SAS congruence. Hence we get the third side. Third side is, first triangle it is BD, second triangle it is AC. Therefore we get BD equal to AC, reason corresponding parts of congruent triangles, that is CPCT. And the third angle, second angle it is angle ABD. We have to prove that angle ABD, isn't it? Angle ABD of first triangle equal to angle BAC of second triangle. ABD, this one, ABD of first triangle equal to BAC of second triangle. These two angles are equal. It is again same reason, CPCT. And angle ABD equal to angle BAC. It is also same reason, corresponding parts of congruent triangles, that is CPCT. Okay. Third question. AD and BC are equal perpendiculars to line segment AB. AD and BC are equal perpendiculars to line segment AB. They are perpendicular to AB and they are equal, these two line segments. Show that CD bisects AB. That is, we have to prove that OA equal to OB, or O is the midpoint of AB, then CD bisects AB, isn't it? Now we have given that AD equal to BC and this angle 1 equal to angle 2, reason both 90. So now we have to take triangles BOC and OBC and OAD. In triangles OBC and OAD, we have BC equal to AD, reason given. BC equal to AD, reason given. Angle 1 equal to angle 2, reason both 90 degree. Angle 1 equals angle 2, reason both 90. The line segments are perpendicular, it is given. Therefore, 1 equal to 2, both 90. And angle 3 equal to angle 4, reason vertically opposite angles, isn't it? Angle 3 equal to angle 4, reason vertically opposite angles. Don't write BOA, you have to write vertically opposite angles. Therefore, we can say that triangle OBC congruent to triangle OAD, reason AAS, isn't it? Two angles and non-included side. Therefore, by AAS congruence, these two triangles are congruent. By AAS congruence. Hence, we get, therefore, OA equal to OB, reason CPCT, corresponding parts of congruent triangles. By using corresponding parts of congruent triangles, these two sides are equal. And that implies CD bisects AB, isn't it? CD bisects AB. OA equal to OB equal to OA. Therefore, OA is the midpoint of AB. Hence, CD bisects AB. Fourth question. L and M are two parallel lines intersected by another pair of parallel lines P and Q. Show that triangle ABC congruent to triangle CDA. We have given that two parallel lines L and M. L and M are two parallel lines and P and Q are also two parallel lines. And they intersect at A, B, C and D respectively. AC is joined. We have to prove that triangle ABC congruent to triangle CDA. Okay. Triangle ABC congruent to triangle CDA. That's to prove. For that, solution in triangles ABC, in triangles ABC and CDA. In these two triangles ABC and CDA, we have angle 1 equal to angle 2 reason alternate interior angles. Since line L is parallel to M, and by considering this since P is parallel to Q, by considering the transversal AC, we get angle 1 equal to angle 2 alternate interior angles. Angle 1 equal to angle 2 reason alternate interior angles, since P is parallel to Q, isn't it? P parallel to Q. The pair lines are P and Q. They are intersected by the transversal AC. Therefore, we get 1 and 2 are alternate interior angles. Hence, they are equal. Similarly, we get angle 3 equal to angle 4. Angle 3 equal to angle 4 since L is parallel to M. Here L and M are two parallel lines and the transversal is AC. So we get angle 3 equal to angle 4 reason alternate interior angles since L is parallel to M. Here the parallel lines are L and M. Again same transversal AC. And we have AC equal to AC reason common side, isn't it? AC equal to AC reason common. AC equal to AC common. Hence by ASA, two angles and included side. By ASA congruence, these two triangles are congruent. That is triangle ABC congruent to triangle CDA reason by ASA congruence. Okay. Once again, in triangles ABC and CDA, we have angle 1 equal to angle 2 reason alternate interior angles since P is parallel to Q and by considering the transversal AC. Okay. Similarly, we have angle 3 equal to angle 4 since L is parallel to M. These two are alternate interior angles and they are equal. Now in triangles ABC and ADC, we have 1 equal to 2, 3 equal to 4 and AC is the common side. AC equal to AC common. Therefore, the triangle ABC congruent to triangle CDA by ASA congruence. Okay. Fifth question. Line L is the bisector of angle A. Line L is the bisector of angle A. And B is any point on L. B is any point on this line L. BP and BQ are perpendicular from B to the arms of angle A. BP and BQ are perpendicular to the arms of this angle. These two are arms of the angle and BP and BQ are perpendiculars. That's given. Show that triangle APB. Congruent to triangle AQB. Congruent to triangle AQB. And BP equal to BQ or B is equidistant from the arms of the angle A. Okay, that's to prove. Now to prove that these two triangles are congruent, take the triangles. In triangles BPA and BQA. In triangles BPA and BQA. These two triangles, we have given that L is the bisector of angle A means angle 1 equal to angle 2, isn't it? Angle 1 equals angle 2 reason given, or L is the bisector of angle A. And angle 3 equal to angle 4 reason both 90 degree. Angle 3 equal to angle 4 reason both 90 degree. Because they are perpendiculars, it is given. BP and BQ are perpendiculars. And we have AB equal to AB reason common side. AB equal to AB reason common. AB equal to AB common. Therefore, we get triangle APB congruent to triangle AQB, APB congruent to AQB, reason AAS congruence, isn't it? Two angles and non-included side. Therefore, by AAS congruence, these two triangles are congruent. Hence, we get BP equal to BQ, reason CPCT. Therefore, BP equal to BQ, reason CPCT, that is corresponding parts of congruent triangles. Okay, or B is equidistant from the arms of angle A, that is BP equal to BQ means B is equidistant from the arms of angle A. That's to prove. Sixth question, in figure AC equal to AE and AB equal to AD. AC equal to AE and AB equal to AD, it is given. Angle BAD, here it is angle 1, equal to angle EAC. Angle EAC, here it is 2. Angle 1 equal to angle 2, it is also given. Angle BAD equal to angle EAC, that is angle 1 equal to angle 2, it is also given. And we have to show that BC equal to DE. If we have to prove that BC equal to DE, then we have to prove that triangle ABC congruent to triangle DAE, isn't it? BAC congruent to DAE, that's to prove. Now for that, we have angle 1 equal to angle 2. Angle 1, that is angle BAD equal to angle EAC, reason given. Angle 1 equal to angle 2, reason given. Now adding angle 3 to both sides by adding this common portion, this short portion, okay, by adding angle 3 to both sides. By adding angle 3 to both sides, we get angle 1 plus angle 3 equal to angle 2 plus angle 3. Okay. Angle 1 plus 3. Angle 1 plus 3 is this complete angle, that is angle BAC. That is angle BAC equal to 2 plus 3. 2 plus 3 is angle DAE, isn't it? Angle DAE. Okay. Now, in triangles ABC and ADE, in triangles ABC and ADE we proved that angle BAC of first triangle equal to angle DAE of second triangle, reason proved, isn't it? Angle BAC equal to angle DAE, reason proved. AB equal to AD, AB of first triangle equal to AD of the second triangle. AB, first side, AB equal to AD, reason given. It is given that these two sides are equal. AC of first one equal to second AE. AC equal to AE. AC is the side of first triangle, AE is the side of second triangle. So AC equal to AE, reason given. It is also given. Therefore, we get triangle ABC congruent to triangle ADE, triangle ADE. Triangle ABC congruent to triangle ADE, reason by considering the first triangle SAS, isn't it? Two sides and include angle by SAS congruence. Okay, two sides and include angles. Hence, we get, that implies we have to prove that BC equal to DE. BC equal to DE, reason CPCT. That implies BC equal to DE, reason corresponding sides of congruent triangles, CPCT. Okay. Seventh question. AB is a line segment. AB is a line segment and P is the midpoint of AB. P is the midpoint of AB. D and E are points on the same side of AB, on the same side, such that angle BAD, that is here it is angle 1 equal to angle angle ABE. Now here it is 2, angle 1 equal to angle 2. And angle EPA, that is angle 3 equal to angle DPB, that is angle 4. And we have to prove that triangle DPA or DAP congruent to triangle EPB. Okay, we have to prove that triangle DAP congruent to triangle EBP. And also we have to prove that AD equal to B. Okay, for that first solution. Angle 3 equal to angle 4. Reason given. It is given that these two angles are equal, isn't it? Now by adding angle phi to both sides, by adding angle phi to both sides, we get angle 3 plus 4. Angle 3 plus, sorry, it is 5. Angle 3 plus 5 should be equal to angle 4 plus angle 5. Angle 3 plus angle 5 means it is angle APD. That is angle APD equal to angle 5 plus 4. 4 plus 5 is angle EPB. Angle EPB. Now take the triangles and prove that they are congruent. Okay. Therefore, in triangles DAP and EBP, in triangles DAP and EBP, we have angle 1 equal to angle 2, reason it is given. Angle 1 equal to angle 2, reason given. Angle 1 equals angle 2, reason given. And we proved that angle APD of first triangle equal to angle BPB. Sorry, it is not B, EPB. Isn't it? EPB of second triangle, reason proved. Angle APD equal to angle EPB, reason proved. And we have AP equal to PB, since P is the midpoint. It is given that P is the midpoint of AB. Therefore, AP equal to PB. AP equal to PB. It is given. Or we can write, since P is the midpoint of line segment AB. Therefore, we get triangle DAP congruent to triangle EBP, reason two angles, isn't it? By considering this triangle, this one and this full angle and the included side. So ASA congruence by ASA, angle and included side, ASA congruence. First part is over. Therefore, we get AD equal to BE, reason CPCT. Corresponding parts of congruent triangles are equal. Therefore, AD equal to BE, reason CPCT. Okay. Now, once again. First, angle 3 equal to angle 4, reason given. By adding angle 5 to both sides, we get angle 3 plus angle 5 equal to angle 4 plus angle 5. That is angle APD equal to angle EPB. These two angles are equal. Now in triangles APB and BPE, angle 1 equal to angle 2, reason given. Angle 3 plus 5, that is angle APD equal to angle EPB, reason proved. And AP equal to PB, since P is the midpoint of AB, it is given. Therefore, we get triangle APD congruent to triangle BPE by ASA congruence. Hence, we get AD equal to BE, reason CPCT. Okay. 8th question. in right triangle ABC, right angle that is C. This is a right angle. M is the midpoint of hypotenuse AB. M is the midpoint of hypotenuse AB. So here AM equal to BM. It is also given. C is joined to M. C is joined to M and produced to D such that DM equal to CM. This is also equal. DM equal to CM. It's also given. Point D is joined to B. DB is joined. Show that triangle AMC congruent to triangle BMD. That is the first part. And second, angle DBC equal to 90 degree, or it is a right angle. That's to prove. Third, triangle DBC congruent to triangle ACB. And fourth part, CM equal to half of AB. Okay. Now, proof. In triangles AMC and BMD. In triangles, first we have to prove that triangle AMC congruent to triangle BMD. So in triangles AMC and BMD, we have AM equal to BM, reason given. AM equal to BM, reason given, or since M is the midpoint of AB, it is given that M is the midpoint, isn't it? And CM equal to DM. CM equal to DM. It is also given. CM is extended to D such that CM equal to MD. It is given. And angle 1 equal to angle 2. Reason vertically opposite angles. Angle 1 equals angle 2. Reason vertically opposite angles, right? Vertically opposite angle, don't write below here. Therefore, we get triangle AMC is congruent to triangle AMC congruent to triangle BMD, reason BMD by SAS congruence, isn't it? Two sides and include angle. SAS congruence, first part is over. Now, hence we get angle 3 equal to angle 4. Angle 3 equal to angle 4, reason CPCT. Therefore, we get angle 3 equal to angle 4, reason corresponding parts of congruent triangles, CPCT. That is, a pair of alternate interior angles are equal, isn't it? Angle 3 and angle 4 are alternate interior angles. That is, a pair of alternate interior angles are equal. Therefore, we get AC parallel to BD. Okay, AC is parallel to DB. But we have given that AC is perpendicular to BC. Therefore, DB is also perpendicular to BC. Hence, we get angle DBC equal to 90. That is the second part. Okay, angle 3 equal to angle 4, reason CPCT. That is a pair of alternate interior angles. Alternate interior angles are equal. Alternate interior angles are equal. Therefore, we get AC parallel to DB. AC. Therefore, we get AC parallel DB. But DB perpendicular to, AC perpendicular to BC given. Yeah. But AC perpendicular to BC, reason given, or the angle is 90 degree, it is given, isn't it? AC perpendicular to BC, reason given. Therefore, we get DB is perpendicular to BC. Since AC and DB are parallel, if AC is perpendicular to BC, then DB also perpendicular to BC. That implies angle DBC equal to 90 degree. That is, angle DBC equal to 90 degree. That is the second part. Now in triangles ABC and ACB, we have to prove that triangle DBC congruent to ACB, isn't it? DBC congruent to ACB. So take that two triangles. In triangles DBC and ACB. In triangles DCB and triangles DCB and ABC and ABC. In triangles DCB and ABC, we have angle 3 equal to angle 4, reason proved. Now DBC and ACB, we have angle DBC equal to angle ACB, reason both 90 degree. These two are 90 degree. These two triangles. In triangles DCB and ABC, we have BD equal to AC, reason corresponding parts of congruent triangles. These two triangles are congruent, we proved. Hence we get DB equal to AC, reason CPCT, since triangle BMD congruent to triangle AMC. We proved that BMD congruent to AMC. So here we can write AMC congruent to triangle BMD, reason SAS congruence. There you write, therefore AD equal to BD equal to AC, reason CPCT. Okay, number this equation as 1. BD equal to AC, CPCT. Now in triangles DCB and ABC, we proved that BD equal to AC, BD equal to AC, reason proved, or from 1. And angle DBC equal to angle ACB, reason both 90 degree. Angle DBC equal to angle ACB, DBC equal to angle ACB, reason both 90 degree. And common side, that is BC equal to BC, reason common. BC is the common side. BC equal to BC, reason common. BC equal to BC, reason common. Therefore we get triangle. Therefore triangle DBC congruent to triangle DBC congruent to triangle ACB, reason SAS congruence, isn't it? Therefore triangle DBC, isn't it? DBC congruent to triangle ACB, reason SAS congruence. Two sides and include angle. Therefore we get, that is the third part, that's over. Therefore we get DC equal to AB, reason CPCT, corresponding parts of congruent triangles. Hence that implies DC equal to AB, reason CPCT. Therefore taking half on both sides, we get half DC equal to half of AB. That implies half of DC. Half of DC is same as half of DC equal to CM. Half of DC is CM and DM. We have to take CM. That is CM equal to half of AB. Reason, since D is the midpoint of CD, isn't it? D is the midpoint, M is the midpoint of CD. M is the midpoint of CD. It is not D, since M is the midpoint of CD. Okay. CM equal to half AB, and that's the last part we have to prove. Now once again, In first part, we have to prove that triangle BMD congruent to triangle AMC. For that, in triangles BMD and AMC, we have DM equal to MC, since it is given that M is the midpoint and midpoint of CD. AM equal to BM, it is also given. Angle 1 equal to angle 2, vertically opposite angles. Therefore, we get triangle AMC congruent to triangle BMD by SAS congruence. Now we have to prove that angle DBC equal to 90 degree. For that, angle 3 equal to angle 4 reason CPCT. Also, you have to take BD equal to AC CPCT. That is, we have to prove that these two triangles are congruent. For that, take BD equal to AC CPCT. Okay, number this equation as first one. BD equal to AC, first equation. We have to use this equation. Now, to prove that angle DBC equal to 90 degree, we have angle 3 equal to angle 4, reason CPCT. That is, a pair of alternate interior angles are equal. Therefore, DB parallel to AC. But AC is perpendicular to BC, reason given. Therefore, DB is also perpendicular to BC, or angle DBC equal to 90 degree. That is the second part. Now we have to prove that triangle DBC congruent to triangle ACB. For that, in triangles DBC and ACB, BD equal to AC, reason from 1. That is, we proved that these two triangles are equal and BD and CA are CPCT, corresponding parts. And angle DBC equal to angle ACB, reason both 90 degree, it's also proved. BC equal to BC, reason common. Hence, we get triangle DBC congruent to triangle ACB by SAS congruence. Hence, we get CD equal to AB CPCT. By taking half on both sides, half CD equal to half of AB. Half of CD is same as CM. We have to prove CM equal to half AB. So, take half of CD as CM. CM equal to half AB. Reason, since M is the midpoint, half CD is equal to CM. Okay, that is CM equal to half of AB. That's to prove. Okay, thank you.